Hi there, this is Mr. Schnitzius, and in this video we are going to go through lesson 38-2, where we're continuing to learn about probability and looking at events involving and or. So our learning targets for this lesson are to understand probability in real-world situations. We're also going to describe events as subsets of a sample space. That's what we learned in the last video. That's the set of all possible outcomes using the characteristics of the outcome. We're going to represent sample spaces as both tables of outcomes and as two-way frequency tables. And we're also going to calculate the probability of events that involve an and also events that involve an or. So we're going to start off on page 559 if you're following along in the Unit 6 PDF. Consider probabilities that involve the words and or. So this is still going to involve the same Springboard Superstar contestants from activity 38-1. So we have the same 12 people here. So first, we're going to choose a contestant at random. Find the probability that the contestant will be female and under 21. Well, in probability, and means the event has the characteristics of both possibilities, sorry. So we want to ask ourselves, how many of the contestants are female who are also under 21? Well, anybody that's a male, we're going to leave out. Crystal is a female, so we're not going to include her. So is Dee Dee. So Crystal and Dee Dee are both females, but they are not under 21. Katie is under 21, and she's a female. All these people are either over 21 or male, but Shaban is a female who is under 21, so we're going to include her. So those are two different contestants who are females that are also under 21. How many contestants are there in total? Well, this is the same set of 12 contestants from the last activity. So what is the probability that the randomly chosen contestant will be female and under 21? Out of 12 contestants in the sample space, 2 are female who are also under 21, Shaban and Katie. So that gives us a probability of 1/6. So now on the next page, in number 2, we're going to find the probability that the contestant will be female or under 21. So we're going to look at the same list of contestants, put a check mark next to any contestant who is either female or under 21 or both. In probability, or always includes the possibility of both. So Aaron gets a check mark because even though he's not a female, he's under 21. Andrew does not get a check mark. Casey does not get a check mark. Crystal gets a check mark because she's female. Dee Dee gets a check mark because she's female. Katie is only going to get one check mark even though she's both female and she's also under 21. Lacey gets a check mark. She's a female. These are males and they're over 21, so they do not get check marks. Paige is a female, so is Shaban. Tim is not a female, but he's under 21, so we're going to put a check mark by him. So if we count this up, that's 8 total contestants who are female or under 21. So the probability that the randomly chosen contestant will be female or under 21 is 8 out of 12, which reduces to 2/3. So now in number 3, we're going to choose a contestant at random from the list of Springboard Superstar contestants. And we're going to find the probability that the contestant has a first name after N. So we'll highlight these people in blue. So this list is alphabetized by first name, L, M, N, O, P. So it has to be after N. L and M are before N. So Paige, P is after N, so is S, so is T. So that gives us a probability of 3 out of 12, which reduces to 1/4. Now we want the probability that someone has a first name after N and is a male. Well, there's only 3 people to choose from with a first name after N, but only Tim is a male also. So that gives us a probability of 1 out of 12. And then when we say has a first name after N or is male. Well, now all the people with first names after N get included. If this is the color that we're using for part C. But if it's an or probability, we need to include all the people with first names after N, but also everybody who's a male. So Lee gets included, Casey, Andrew, and Aaron all get included. So if we count up how many people we highlighted, Michael gets included too. How many people did we highlight? 1, 2, 3, 4, 5, 6, 7, 8. So that gives us a probability of 8 out of 12, which reduces to 2/3. So on the bottom of page 560, this gives us an example of using a two-way table instead of a list. Kathy likes Honeycrisp breakfast cereal. Each box of Honeycrisp contains a plastic animal, a monkey, an elephant, a caribou, or a bear. And each of these 4 animals is equally likely to be found in any given box. Kathy's younger brother, Brian, prefers Corn Invader breakfast cereal. Each box of Corn Invaders contains either Hero Comic 1, Hero Comic 2, or Hero Comic 3, and each of the comics is equally likely to be found in any given box. Tomorrow, Kathy will open a new box of Honeycrisp, and Brian will open a new box of Corn Invaders. They will find out what prices they have. So here is a table that represents the sample space for this probability experiment. These are the possibilities for what we could get out of the Honeycrisp box, and these represent the possibilities for what we could get out of the Corn Invaders box. So using the eraser end of the pencil, we're going to locate the cell that represents getting an elephant and Hero Comic 2. That would be right here. So if we think about which of the cells represent getting a caribou, that would be these cells right here in the 3rd row. Which of the cells represent getting Hero Comic 3? Well, that would be any of the cells. That would be any of the cells in column 3. So if we put colors to that, that would be any of these cells here. So now it says, how many outcomes are there in the sample space for this probability experiment? Well, there are 3 possibilities in each row. 3 times 4 possible outcomes from the Honeycrisp breakfast cereal gives us 12 possible outcomes. We can see that just by counting up how many boxes there are. So if we locate the cell in the table that represents getting an elephant and Hero Comic 2, that's only 1 cell out of the 12 possible outcomes. So that gives us a probability of 1/12 of getting an elephant and getting Hero Comic 2. So now we're going to find the probability of getting an elephant or Hero Comic 2. So we're going to write stars in all the cells of the table that represent getting an elephant or Hero Comic 2. So we have to put in all the ones for elephant, and then we have to put a star in all the ones for Hero Comic 2. We're not going to put 2 stars in this box because we already identified this box as one of the outcomes where we get an elephant or Hero Comic 2. So how many stars did we just put down? 1, 2, 3, 4, 5, 6. So that means the probability that we get an elephant or Hero Comic 2 is 6 out of 12 possibilities in the sample space, which would reduce to 1/2. So now this is on page 562. This is another example of a two-way table. A two-way frequency table shows data that pertain to two different categories. So this is like the two-way table that we had in the last problem, except now, whereas here each of these was equally likely, here you're more likely to have caller ID and a speakerphone than you are to have caller ID and no speakerphone. So let's read the setup for this problem number 6. A store has 48 different phones available with or without caller ID and with or without a speakerphone. The number of phones with and without these features are shown in the two-way frequency table below. So how many of the phones have caller ID? Well, in this row, there are a total of 20 phones. So that's the answer to part A. What is the total number of phones that the store has available? We can see that if we total up the caller ID and no caller ID phones, we get 48. That's 20 plus 28. Or if we have 34 speaker phones plus 14 phones without speaker phones, that also gives us 48. So that's the total number of phones that the store has available. And then part C says, if a phone is chosen at random, what is the probability that it has caller ID? Well, that would be how many phones have caller ID? 20 out of the total number of phones in the sample space. And then if we put 20 over 48 in our calculator and round it to 3 decimal places, it's approximately 0.417. So here are some other problems that they want us to solve using this two-way table. A phone is chosen at random from the ones available at the store. To 3 decimal places, find the probability that the phone has a speakerphone. There are 34 phones that are speakerphones out of 48. So 34 over 48 is approximately 0.708. What's the probability that a phone has a speakerphone and caller ID? So here are the speakerphones. Here are the caller ID phones. So if we highlight both of those rows, both this row and this column, we're interested in where that row and column intersect. So that gives us 18 phones that are speakerphones and have caller ID. So that gives us a probability of 0.375. Number 3 says it's a speakerphone, but it does not have caller ID. So if it's speakerphone, we're in this column, but we want no caller ID. So that would be 16 phones out of 48 would be 0.333. And then we want to find the probability that the phone has a speakerphone or has caller ID. Well, that would be how many are speakerphones? Well, that could be 18 that do have caller ID. That could be the 16 that have speakerphone and that do not have caller ID. But we want to include all the phones that have caller ID also. We already included 18 of those, but we have 2 more over here to include. So 18 plus 16 plus 2 divided by 48 gives us a probability of 0.75. All right, lastly, there's a check your understanding problem here at the bottom of page 563. Students who take an AP Calculus exam can take either the AP Calculus AB exam or the more advanced AP Calculus BC exam. On each exam, the highest possible grade is a 5 and the lowest is a 1. No student takes both exams. The approximate results in thousands for 2011 are summarized in the table below. For example, the table tells us that 39,000 students took the AB exam and got a 5. That's right here. So we're going to complete the table by writing the row and column totals in the empty cells. Well, we know that 39 plus 28 would give us the total number of students that got a 5, so that would be 67. And remember, this is in thousands, but I'm just going to put the numbers in the cell. 32 plus 10 is 42. 35 plus 12 is 47. 23 plus 4 is 27. And 65 plus 8 is 73. Now we have 2 ways that we could go about finishing this. It's going to be about the same amount of typing either way. If we add these 5 values in the bottom row, that will give us the total number of test takers for both tests. If we add 28 plus 10 plus 12 plus 4 plus 8, that'll give us the total number of students that took the BC calculus exam. So if you add those 5 values, you get 62. And then 194 plus 62 is 256, which is the same thing that we would get if we added 67 plus 42 plus 47 plus 27 plus 73. So here is the completed table. That matches up what we wrote over here, just working it out on our own. So part B says, suppose that one of these 256,000 students is chosen at random. Using a calculator and giving your answers rounded to 3 decimal places, find the probability that the student 1 took the BC exam. So we're going to do the work as fractions over here, and then over here it'll show us what the decimals are. How many students took the BC exam? 62,000 out of 256,000. And if you put that in your calculator, you will get 0.242. 2 says got a 5. Well, how many total students got a 5? 67,000 out of 256,000. And if we convert that to a decimal, it should be slightly more than 0.242. It's 0.262. 3 did not get a 5. So there's a couple different ways to work this out. We could add together the 4s plus the 3s plus the 2s plus the 1s, or we could do 1 minus 67 out of 256, which would be 1 minus 0.262, which as a decimal would be 0.738. So there's the answer there. Number 4 says, took the BC exam and got a 5. So how many students took the BC exam? That's everybody in this column. But we also want to include the students that got a 5. So that would be the students in this cell right here. So that would be 28,000 out of the 256,000 test takers. And if we convert that to a decimal, we're going to get 0.109. And then lastly, we want to, let me repair what I erased real quick. That's 62 and that's 67. Lastly, we're going to circle everybody that took the BC exam or got a 5. So that would be 28,000, 10,000, 12,000, 4,000, and 8,000. But then we also need to include the 39,000 who got a 5 taking the AB calculus exam. So if we add all that up, that's 39 plus 28 plus 10 plus 12 plus 4 plus 8 all over 256. And if we convert that to a decimal, we get 0.395. So that's it for activity 38. Thank you guys for watching and thank you for your hard work. Hope that you have a great day.